Have you ever just wondered what Mars actually sounds like?
Right.
I mean, we all have this picture of a silent, dusty planet. But what if I told you it crackles?
Mm.
NASA's Perseverance rover just sent back an answer to a question we thought was pure science fiction. Does lightning on Mars make a sound?
And the answer is a definite yes. It's a tiny sound, but it's there.
So today, we're doing a deep dive into that, the first ever direct detection of these electrical crackles, what they tell us about the red planet, and what this all means for the future of humans there.
Well, the real breakthrough is the sound itself, the acoustic signature.
Okay.
The SuperCam microphone on Perseverance didn't just register some electromagnetic interference. Over 2 Martian years, it recorded 55 of these discharge events.
55.
Wow. And 7 of those came with a tiny sonic boom. You get the electrical blip and then boom, this little thwack of thunder. It's the first time we've ever heard that.
And I'm guessing these sparks aren't just happening randomly.
Not at all. They're tied directly to Mars's wildest weather. We're talking the absolute strongest winds, the fronts of massive dust storms, and especially inside those big dust devils.
So the weather is literally generating the electricity.
Exactly. The mechanism is something called triboelectricity.
Which is just a fancy term for static electricity, right?
That's all it is. You have all these little silicate dust grains in the wind rubbing against each other at high speed. They build up charge, and then zap! They release it.
Okay, but hold on. You're saying this is tied to the most intense weather, yet the biggest discharge they measured was, what, 40 millijoules? That's less than the shock you get from a doorknob.
Yeah.
How is that a breakthrough for future astronauts? It sounds tiny.
It is tiny, but it's the principle of it. Researchers are calling it mini lightning, maybe centimeter-scale arcs.
Okay.
The reason it's a big deal is because Mars's atmosphere, that super thin carbon dioxide atmosphere, makes electrical breakdown about 100 times easier than it is here on Earth.
100 times easier.
So a tiny bit of charge goes a very, very long way. It confirms the whole environment is electrically active.
And this isn't a new idea, is it? I mean, scientists have suspected this for decades.
Oh yeah, theories go all the way back to the Viking landers in the 70s. There was even a study in 2009 that picked up microwave signals, which were basically radio waves from static sparks.
But they couldn't hear it or pinpoint where it was coming from.
Exactly. They saw the flash, so to speak, but they couldn't hear the thunder until now. And confirming it has these huge chemical implications for the atmosphere.
Oh, so.
Well, all that constant low-level sparking could actually destroy organic molecules. That's something we have to factor into the search for ancient life. And it's now thought to be the main engine behind the entire Martian chlorine cycle.
So it's fundamentally shaping the planet's chemistry.
It really is.
Which means this immediately changes how we have to build things for future missions.
Absolutely. You have to protect sensitive electronics. You have to think about astronaut spacesuits and this constant electrostatic hazard. It forces us to design a whole new generation of tougher, more resilient instrumentation.
That drive to innovate so quickly must be a massive challenge.
It is, and that's not just in space exploration. That's in every sector right now. Actually, if you're trying to figure out where agents could make the most impact for your business, or even just for you personally, you should check out embersilk.com. They focus on exactly that: AI training, automation, and software development.
So this tiny crackle on Mars is teaching us fundamental lessons in planetary engineering.
It really is. We now know that electrical activity is a constant, measurable force on Mars. And the most exciting part is that we're learning this now. We can design for it. We can build smarter, more resilient habitats and rovers.
So it's not a problem. It's just a new design parameter.
Precisely. Every piece of data like this just proves we can adapt and overcome these planetary challenges. It brings us one step closer to making Mars a second home.
Another secret of the solar system unlocked, one tiny spark at a time. Thanks for tuning into this deep dive. If you enjoyed this, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out.